Hi there, this is GCSE Physics, and this is Atomic Structure Lesson 4, The History of the Atom, Part 2. So the objectives are to recap the content from the Rutherfords Scattering experiment, and recall who discovered the neutron, and understand Niels Bohr's model of the electron. Alright, so here's an exam style question to start with. Make sure you've done the lesson previous, or you actually just understand Rutherford's model. So the image on the right hand side illustrates the gold leaf experiment that led to the nuclear model of the atom. So what you need to do is explain how the paths of the alpha particles were used to develop the nuclear model of the atom. So basically, what did these results tell the scientists? Okay, so you're going to pause and have a go at that, see what we come up with, and then I'll take you through the answers. So firstly, the vast majority of alpha particles pass straight through the atom, undeviated, which means they don't change direction, which shows that the atom is mostly empty space. A very small proportion of alpha particles are deflected through much larger angles, which shows that the atoms must contain a dense nucleus where the mass and the charge, and the positive charge of the atom, is concentrated. Remember, the alpha particles are 2 protons and 2 neutrons, so they've got a positive charge. So when they came into contact with the gold nucleus, or came close to the gold nucleus, they would repel. So obviously, Rutherford, Ernest and Marsden. Rutherford, Geiger and Marsden. Ernest is Rutherford's first name. Bit of an history lesson. They obviously knew that alpha particles were positive, therefore they established that the nucleus, in this case the gold nucleus, must have must be positively charged as well. So last point, the alpha particles are positive, so the charge of the nucleus must also be positive. So hopefully that one went okay and you hit most of those points. If not, make sure that you've got them written down and study that type of question in case it comes up. Okay, let's move on. Discovery of the neutron. You just need to be aware of this. You don't need to know about the experimental procedure or anything. So in 1932, the experimental work of James Chadwick provided the evidence to show the existence of neutrons within the nucleus. So Chadwick, in this way, prepared the way towards the fission of uranium-235 and towards the creation of the atomic bomb. For this epoch-making discovery, he was awarded the Hughes Medal of the Royal Society in 1932 and subsequently the Nobel Prize for Physics in 1935. Again, you just need to be aware of what James Chadwick did, but you don't need to know any experimental details. If you want to read up about it, that's completely up to you. Okay, let's move on. Niels Bohr. So Niels Bohr produced the idea of electrons residing or existing in discrete energy levels. You do energy levels in chemistry, or they call them energy shells. Shells and levels are basically the same thing. So what you need to know for your exam is that you can get incoming photons of energy. A photon is basically a light ray. So light can come in, or you could say electromagnetic radiation, which if you've done waves is stuff like, X-rays or light or UV light or gamma rays. They can come in, they can hit an electron that's in orbit in one of the energy shells. Okay, so you've got a ground state energy level, which is the first one. So let's say there's an electron residing in there. So light can come in, or electromagnetic radiation, give that electron energy, and it can jump up into a different energy level or a different shell. And we say that it's excited. You could get asked exam questions that basically just want you to understand that. So electromagnetic radiation comes in, hits an electron, jumps up into an excited energy level, and that's it. So this is it in writing. Electrons can absorb energy from light, be that photon or electromagnetic radiation, and are excited into a higher energy level. You might be asked what happens after it's excited. So when the excited electron drops back to a lower energy level, you can get light being released. So if that one dropped back down, you would get light coming off. Or a photon. Remember, photon's just a posh name for light, essentially, which you'll learn more about when you do, or if you do, A-level physics. And I've only ever seen one exam question on this. It is relatively new. It was introduced when the specification last changed, for the AQA especially. So this question is very similar. So if you want to pause and have a go at this one, and then I'll take you through the answer. So Niels Bohr adapted the nuclear model by suggesting electrons orbited the nucleus at specific distances. Explain how the distance at which an electron orbits the nucleus may be changed. So I'll go for the answer now. So an orbiting electron may absorb electromagnetic radiation, you could have said photon or light, and move further from the nucleus, excited into a higher energy state, to a higher energy level. And that's basically it. Remember, it could ask, but I'm not sure, it could ask what happens afterwards, or what happens when it comes back down. So the light will drop into a lower energy level and emit some electromagnetic radiation, or emit a photon, or emit some light, something along those lines. I've not seen that asked yet, but for the level 8-9 questions, that is a possibility. So just be aware of that. Anyway, that completes the history of the atom, the first two, lesson 3 and lesson 4 on atomic structure. So hopefully that's okay. Thanks for watching, and I'll speak to you soon.